Relative masses of atoms and molecules.
Welcome to all NSSC Advanced Subsidiary Chemistry learners and everybody else interested in chemistry. We appreciate your company. From NAMCOL, the Namibian College of Open Learning, we have a series of 5 radio lessons on different interesting topics in your Advanced Subsidiary or AS Grade 12 Chemistry syllabus. In Lesson 1, we discussed the framework structures of crystalline solids. Then in Lesson 2, we had great fun submitting 4 Group 2 elements to experiments to see how they reacted to oxygen and water. Today in Lesson 3, the relative masses of atoms and molecules. If you are a NAMCOL student, you will find this topic right in the beginning of your textbook, AS Level Chemistry Learner's Book, as topic 1.1 on pages 3 to 5. If you are having challenges with Group 2 elements and working out their relative mass, this is the place where you can shake off that fear and get to know once and for all how the periodic table works. It's a very clever scientific tool, you know. We have one learning objective for this lesson to help you define and use the terms relative atomic mass, isotopic mass, molecular mass, and formula mass. I can see that my student Ushona is already in class waiting for me. Please join us. Hi there, Ushona.
Good day, Miss Poulton. I heard you say we're dealing with atoms today, but we can't trust atoms.
What are you talking about, Ushona? We can't trust atoms. Why?
Because, miss, they make up everything.
Just now, you'll tell me that joke about the new metal that's been added to chemistry.
I don't know any such joke, ma'am. Please tell me.
I'll think about it, maybe after class. For now, let's focus on the work. So today, we are going to talk about those small particles that, as you say, make up everything.
Atoms?
That's right. Atoms are the smallest building blocks of matter.
But what about molecules?
Good question. Atoms combine to form molecules, like 2 atoms of oxygen combine to form an oxygen molecule. Elements or atoms do not exist alone, but combine to form molecules or a compound that can exist on their own.
Are atoms visible? I guess not. If they are the smallest part that any matter consists of, I have always wondered if anyone has seen these particles, how small they are.
Those are very good questions, Ushona. They get us straight into the lesson. The mass of a single atom is so small that it's impossible to weigh directly on a balance. To overcome this problem, the chemists found a way to compare the mass of any particle with the mass of one atom of carbon-12 as the standard. Therefore, they call it relative mass. This means that the mass of an atom is taken as relative to the average mass of an element with 1/12 of the mass of a carbon-12 atom. It is a little difficult to explain, but the mass of an atom is basically expressed as a multiple of 1/12 the mass of the carbon-12 atom, which is assigned an atomic mass of 12 units. To give you just an idea of the scale, 1 atomic mass unit, or AMU, atomic mass unit, corresponds to 1.660539,040 times 10 to the power minus 24 gram.
Yo, that's very, very, very small.
Yes. The atomic mass is slightly less than the sum of the masses of the protons, neutrons, and electrons that make up an atom. Most atoms exist as mixtures of isotopes. Like hydrogen, for example, has 3 isotopes. So the relative atomic mass is the average mass of those 3 isotopes or atoms of the element, relative to 1/12 the mass of an atom of carbon-12.
Okay, it's kind of making sense now, but I'm not familiar with the term isotopes. What are those?
Oh, Ushana, but you should know about isotopes. We did it in earlier grades. Isotopes are atoms of the same element having the same atomic number but different mass numbers.
At least I know where to find the mass numbers. They are written at the top left corner of the symbol of every atom.
That's right. So now that you know what isotopes are, I would like to introduce another term, relative isotopic mass. This is defined as the mass of one atom of the isotope of an element relative to 1/12 the mass of an atom of carbon-12. For example, carbon has 3 isotopes, carbon-12, carbon-13, and carbon-14. The relative isotopic mass of carbon-12 is 12.0. The relative isotopic mass of carbon-13 is 13.0, and so on.
Okay, yes. So I once read that there is a machine called a mass spectrometer that can be used to measure the mass of each isotope in an element. Is that true, miss?
Yes, that's right, Ushona.
And molecules? How are they different from atoms?
Molecules are also small particles. A molecule is a group of atoms bonded together. Can you give me an example of a molecule?
Water. A water molecule. It consists of an oxygen and 2 hydrogens.
That's correct. Another molecule?
Carbon dioxide. It's made up of a carbon and 2 oxygens.
Thank you. So, as you can imagine, the masses of molecules are also too small to be measured directly on a balance. So the relative molecular mass is used. It is defined as average mass of the molecules compared to 1/12 the mass of an atom of carbon-12. So, to find the relative molecular mass, we add up the relative atomic masses of all the atoms present in a molecule.
I do see. So if, for example, I want to find the relative molecular mass of water, I first write the formula of water. This helps me to see which atoms are present in the molecule. In this case, 2 atoms of hydrogen and 1 atom of oxygen makes us a water molecule. So then we add up the relative atomic values. The relative atomic mass of hydrogen is 1.0, but there are 2 atoms, so it's 2 for hydrogen. The relative atomic mass of oxygen is 16.0, and there is only 1 atom, so I add 2.0 and 16.0 and get the relative molecular mass of water as 18.0.
Very good, Ushana. Now, molecules are covalent. If a compound is ionic, we find its relative formula mass instead. It is also calculated in the same way. Try calculating the relative formula mass of magnesium hydroxide. Mg open bracket OH close bracket 2. It's the final thing we will do today. I give you a few seconds to get the answer.
Is it 58.3?
Excellent. But how did you get it?
Well, you said magnesium hydroxide is written Mg with OH in brackets and a small 2 after the bracket. This means the molecule consists of 1 magnesium, 2 oxygens, and 2 hydrogens. And so I have to add these up in terms of their relative atomic mass. Magnesium has a relative mass of 24.3 plus the relative atomic mass of the bracket with oxygen with its mass of 16.0 plus hydrogen 1. Then the bracket is multiplied by 2. This means the oxygen of 16.0 plus hydrogen 1 is 17. Multiplied by 2 is 34. The 24.3 of magnesium plus the 34 of the hydroxide in brackets makes a total mass of the magnesium hydroxide of 58.3.
Well done, Ushona. And thank you to our listeners and learners for joining us listening today. It is hard to focus on formulas and numbers on a radio program, and we hope you could learn what we set out for you to learn about the relative masses of atoms and molecules, which was that atoms are the smallest building blocks for all matter and the smallest part of an element that can exist with its full identity. A molecule is a group of atoms bonded together, which could also consist of different atoms. A molecule is the smallest part of an element or a compound that can exist alone. A single atom or molecule is too small to weigh directly on a balance. Chemists have therefore established the masses of atoms or molecules as compared to the mass of an atom of carbon-12 as the standard. Therefore, atomic mass is always relative to the mass of carbon-12. Relative atomic mass, written with the symbol AR, is the average mass of an atom of an element relative to 1/12 of the mass of one atom of carbon-12. A molecule consists of a fixed number of atoms joined together by covalent bonds. The relative molecular mass is calculated as the sum of the relative masses of the atoms the molecule consists of. And the relative isotopic mass of an element is also defined as the mass of one atom of the isotope relative to 1/12 of the mass of one atom of carbon-12. The relative formula mass of a substance is the weighted average of masses of the formula units relative to 1/12 of the mass of one atom of carbon-12. Relative formula mass is a much more useful term than relative molecular mass because it includes everything whatever the bonding. It works equally well for ionic and for covalent substances. And this wraps up our program for today. Remember that NAMCOL has many more radio lessons that can help you brush up on important school topics in your grade. Thanks for tuning in. Join me again soon.
Wait, don't stop it yet.
Is there something you still wanted to say, Ushona?
Yes, ma'am. I would like to hear that joke you talked about the new metal that they had added to chemistry.
If you remember well, Ushona, it was actually a joke I did not want to tell, being a woman myself. But I'm sure you have now made the whole country curious about this joke. So, okay then. A new metal has been added to chemistry. Its name is woman, symbol Wm. Its atomic mass is light when first found, tends to get heavier with time. I'm not done. Its physical properties include that it boils at any time, can freeze at any time, melts if treated with love, and very bitter if mishandled.
Oh, I love this joke. It sounds like my mom is the middle.
This lesson is produced by NAMCOL with funding from the Ministry of Education, Arts and Culture.